Welcome back to the lecture series on mathematics using Python. Here, in this video, I will be talking about logarithms and trigonometry using Python. Okay. Now, here what I do is I first of all import math, which you can see on your screen. This is for calling the mathematical stuff. Okay, and then print math.log 1024 to the base 2. Why? Because 2 multiplied by 2 multiplied by 2 multiplied by 2 10 times, this is equal to 1024. Similarly, 2 to the power 7, this is equal to 128, because if I keep on multiplying 2 by 2 by 2 by 2 by 2 by 2 multiply by 2, I get 128. Similarly, here you can see 6 zeros over here, 1, 2, 3, 4, 5, 6. Okay. Why? Because if I multiply 10 with itself 6 times, I get this figure. Okay. It looks like, I guess, 1 million. Okay. And here any number 2 to the power 0, this is equal to 1. Okay, because you take any number n. Okay, this is the comment. Okay, so you take any number n to the power 0, this is equal to 1. Similarly, you take the base 2 or you take the base 10. Currently Python is supporting only two bases, log base 2 and log base 10, but in future if they introduce a new base, I will not comment on it, but surely there are many indirect formulas to work around it. Okay, so and another number num. Okay, if you raise to the power 0, you any number to the power 0, this is equal to 1. Okay, so let me save it, and now I am executing this code and start with debugging. Okay, zoom control plus plus plus. Okay, here you are. Okay, so 2 to the power 10, this is 10. This is equal to 1000. 2 to the power 10 is equal to 1024. 2 to the power 7 is equal to 128. I'm getting 7. Then here 10 to the power 6. Okay, and here 0 zeros, which I have already explained to you. Interesting fact is that Python can also support normal trigonometry and hyperbolic trigonometry, which is used for the curves. Okay, let me give you example of a curve in real life. I guess it is a rugby ball. I mean, everybody has played a rugby. It is a very famous game. So for those kind of things, because it's not a normal complete sphere, just like a football or basketball or a cricket ball, it has got some sort of a curve. Okay, so in those kind of situations, you'll be using hyperbolic tan over here. Okay, so C math is I'll call it okay, import math. After that, I have written import C math because Python accepts complex numbers, and it is generally a sort of a method. Okay, so here I have taken 1 radian is equal to 57.2958 degrees. Okay, so first of all I'm calculating print math dot sine r, where r is equal to 1 and radian, and r is equal to 1 radian, and 1 radian is equal to 57.295 whatever degrees. Okay, then here I'm taking print math dot cos, I'm taking the cosine value of it. Here I'm taking print math dot tan, I'm taking the tan value of it. Okay, so this is the inverse of it. Okay, print math dot inverse of sine, print math dot inverse of cos, print math dot inverse of tan, which is equal to cot theta. Okay, here is hyperbolic sine, print math dot sine hyperbola, print math dot cos hyperbola, print math dot tan hyperbola. Okay, and here is the inverse of print math dot inverse of sine hyperbola, print math dot inverse of cos hyperbola, and here print okay, why I use C math over here, and you can see something abnormal over here. Instead of radian, I've used 1.11. Why? Because sometimes, because of limitations of mathematics, I may be getting because I have run this code many times before coming up with this video. Many occasions I was getting say complex numbers, or I was getting some sort of infinite, or I was getting exceptions. Okay, some sort of unnatural results I was getting just to get some sort of a normal result. Here also I'll be getting complex number as the output. Okay, so okay, so for that just to avoid any sort of abnormal condition. Okay, so print okay, so this is inverse of hyperbolic I'll call it 10. Okay, so I guess this should work, or rather this has worked many times earlier also. And here's the output. Okay, so let me zoom it for your convenience. And here you can compare the comparatively inputs and outputs. Okay, so let me zoom out a little bit for the convenience. Okay, 1 2 3 4 5 6 7 8 9 10 and 11 12. Okay, I guess this is totally okay. Now let me just go first of all. Okay, so sine is 0.841, then cos is 5.4, tan is 1.555, inverse of sine is 1.57, then inverse of cos is 0, inverse of tan is 0.785, or okay, then sine hyperbola is 1.75, cos hyperbola 0, okay, sorry, 1.543, then tan hyperbola you can compare. Okay, and that is 0.765. Inverse of sine hyperbola, that is 0.881. Okay, and second last one I'm getting 0. This one, last one, which was little abnormal, here I am getting some sort of a complex number. Okay, I plus j, because iota plus j, I mean, this is how a complex number looks like. Okay, so that's all, and thank you.